We are going to go through question 7 from the problem solving section of the M1 homework. So we are given that the plank of a pirate ship is 4 meters long, uniform and of weight 25 G. So that can be modelled as a rod of length 4 meters and it's uniform, so we say that its weight acts at 2 meters from this end. So let's start to label our rod, we'll call it AB. We're told that there is a cable at one end and it is balanced on the ship at a distance of 1.5 meters from that end. The cable can sustain a maximum tension of 100 G newtons before snapping. So, this is the side of the ship here, 1.5 meters from the end. So you can imagine that the plank is going to go that way, so the cable will have to be acting this way. So we're going to have a tension at A, and I'm going to call my pivot P. Find the maximum weight that a miscreant can have if he is to successfully reach the seaward end of the plank without being tipped into the water. So miscreant means ne'er-do-well, someone who's going to be pushed over into the sea below. So they're walking and they're going to reach B. And they've got a weight W. And we want to find what that weight can be without them falling over. So the maximum tension that the cable can stand before it snaps and they fall over is 100 newtons. So let's assume T is equal to 100 newtons. Now we've got a reaction force here at P that we don't know. So let's take moments about P. So taking moments about P in a clockwise direction, this distance here must be 0.5 meters. So our clockwise moments, we have 25 G times 0.5 plus, well, the whole plank is 4 meters, so this distance must be 2.5 meters, so 2.5 times W is going to be equal to 1.5 times the tension, which was 100. So 1.5 times 100. So we've got W is equal to 150 minus 25 over 2G all over 2.5. And I'm just going to consult my calculator. That gives a weight of 55 G newtons, so a mass of 55 kilograms. Now, in part 2, we are asked to find how far from the side of the ship a man of mass 75 kilograms can walk before the plank starts to tip. So, they're no longer here. They are walking from the side of the ship an unknown distance. So let's call that X. But we know their weight now is 75 G. If this is the maximum distance they can walk, we again know that the tension must be 100. And if they walk any further, the cable will snap and they will fall into the sea. So again, taking moments about P, we have the 25 G times 0.5. This term is the same. Plus 75G times X, the unknown distance that we're trying to find, is equal to 1.5 times 100 again. So X will be equal to 150 minus 25 over 2G, all over 75G. And consulting my calculator, that gives us an answer of 1.83 meters.